everyone. Welcome to another episode of It's Your Grade. I am your host, Sarah. In today's video, we're going to have an introduction to the periodic table, where elements are located, how their ions are formed, what the charges of these ions are, and how it relates to ionic compounds. First, I'd like to note that the left side of the periodic table is where you will find your metals, which will have positive charges. And the right side of the periodic table is where you have your nonmetals, which can form negative charges. But there are some key things to note. So I'm going to just draw this little line here, which is often known as the staircase line. And the staircase line kind of separates the metals from the nonmetals. But if you'll notice, there are some metals or there are some elements that are known as metalloids or semi-metals. And these are the ones I'm going to continue highlighting with purple. So you have boron, silicon, germanium, arsenic, antimony, which by the way has an interesting chemical symbol. Sometimes the chemical symbols, if you would have noticed, like carbon has a C for it, but antimony, which starts with an A, its chemical symbol is Sb, which might not be intuitive. I forget what the Latin name is, but I'm sure that it comes from the Latin name. You will also notice that is true for elements like silver is Ag or gold is Au. Au is aurum, which is Latin. You'll also notice that's true for lead, Pb, which is one of my favorite elements just because of the Latin name. Pb comes from the name plumbum, which is just a fun word to say. Anyway, so if we were to look at the periodic table and the very first column here all the way on the left, which has hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, everything that's located in all the elements that are located in the same column have the same charge. They have a +1 charge, and you will later learn that they also have similar properties. Now, you might have noticed that hydrogen is not actually a metal. It is a non-metal. It is our only positive non-metal, and it has a +1 charge, located once again in this first column. Everything below hydrogen are known as the alkali metals. And once again, these have a +1 charge. If you were to take lithium metal, which typically the metal itself is neutral, if you were to remove an electron from lithium, you would then have more protons than you have electrons, and lithium is left with a +1 charge. And so that's how everything in that first column works. Then the next column, column 2, no surprise, everything in this column have a +2 charge. Beryllium, magnesium, calcium, strontium, barium, and radium. Everything here in the middle, columns 3 through 12, these are known as your transition metals. And why are they transition metals? Well, if we think about the word transition, it means to move between things, to transition between things. Unlike the metals of the first two columns, which have fixed charges of +1 if you're in the first column or +2 if you're in the second column, transition metals can have different charges depending on what other elements or atoms they are paired with and how many they are paired with. So as an example, iron, here in the 8th column, atomic number 26, iron can have a +3 charge, it could have a +1 charge, it could have a +2 charge, depending on what it's paired with. And we will learn how to not only name but also come up with the ionic formulas associated with various transition metals in later videos. And you can't memorize and I definitely do not recommend you memorize the charges of transition metals. Um, you can do that easily with a periodic table for everything in the first two columns to memorize those charges, +1, +2 as you go from left to right. But for transition metals, it comes down to being able to figure out the charge based on what it's paired with. And we're going to learn that in a different video. If we keep moving to the right, everything in column 13, which if we just get rid of that one there, there's a 3, so it has a +3 charge. Everything in column 13 has a +3 charge: boron, aluminum, gallium, indium, thallium, and niobium. All of these have a +3 charge, although you probably won't really see too much lower than gallium when you're looking at ionic compounds, because things get a little bit more complex the lower you go in the periodic table, because there's a lot more electrons and things that can happen. Um, we'll ignore column 14 for now. This is where carbon is located and silicon. You will see these more in organic chemistry. Organic chemistry is the study of carbon. Typically, carbon is not making ionic bonds. It's going to make covalent bonds, such as in carbon dioxide. And so, although this column technically has a +4 or sometimes a -4, you probably won't have to worry too much about it if you're talking about ionic compounds. So we'll ignore that for now. I want to jump over to the far right side of the periodic table, column 18. Everything in this column, these are known as your noble gases. And they're noble gases because the outermost energy level, or the outermost shell that contains electrons, is full. Like, it has the maximum number of electrons that it can hold. For neon, argon, krypton, and so on down the periodic table, they would have 8 electrons in their outer shell. It's known as the octet. You will learn about the octet rule and all the energy levels of electrons later on, especially in later videos. And helium has atomic number 2. It only has 2 electrons, 2 protons, so therefore it has 2 electrons in its outer shell. That's a lot of just a little bit of extra information there, but we'll carry on with figuring out where our charges are. And I do encourage you to have a copy of a periodic table and go ahead and mark it up, put these charges in, really become familiar with the periodic table. I actually gave a speech tonight at a Toastmasters group, and I explained how the periodic table is the equivalent of a dictionary in you were learning English. So the periodic table is a reference guide. It's something you should go back to. You should always have one handy, become familiar with it. Um, yeah. So column 17, these are where your halogens are located. And the halogens, so fluorine, chlorine, bromine, and iodide, these all have a -1 charge. And then if we keep going towards the metals, so column 16 with oxygen, sulfur, and selenium, these have a -2 charge. Nitrogen and phosphorus, they have a -3 charge. There are a couple metals that I do want you to remember, and I know I said not to memorize any transition metals whatsoever, but um, these are easy to remember, and it's helpful once you get into naming ionic compounds and working with ionic compounds, coming up with ionic formula and whatnot. And that if you remember aluminum, and you can remember aluminum because it's in the +3 column, and you just kind of like go downstairs. Again, more stairs in the periodic table. So we got aluminum, zinc, and then silver. And if you just remember 3, 2, 1, so zinc has a +2 charge and silver has a +1 charge. And of course, aluminum in the +3 column has a +3. So you really only need to remember aluminum. And then if you count down in a stair-like fashion, you have 3, 2, 1. Um, there was something else I wanted to talk about here. Oh, yes. So that pretty much sums up where your basic types of elements are in your periodic table. You have your metals, your transition metals, and your non-metals. You got to know where your halogens are, your noble gases, and +1, +2, +3. As you start on the left side of the periodic table and go over, remember that boron is +3. And then if you start one over from the noble gases, that's where you have your -1 charge, -2, -3 when you end up in the nitrogen column. This is a little bit of a tidbit. It is sort of related to ionic compounds. It's definitely related to naming acids and bases, and eventually you'll be learning about which acids are strong and which bases are strong. So I just thought I would throw this in here. If you're having a periodic table and marking it up, it's going to come up rather quickly as things start to build quickly in chemistry once you lay your foundations. So if you just start with lithium, because that's your first alkali metal, and if you were to kind of make a zigzag line, and you would go down, so you have lithium, sodium, potassium, calcium, strontium, and barium. And all you need to remember that if you take any of these metals and you were to pair it with a hydroxide ion, by the way, is a polyatomic ion, and I'm sure there'll be a video about polyatomic ions coming up soon. But if you were to take lithium and paired it with hydroxide, LiOH, for example, you'd have lithium hydroxide. That's a strong base. Sodium hydroxide, you've all have heard of sodium hydroxide, I'm sure, also known as Li. That's a very strong base. Potassium, calcium, strontium, barium, these all bond with hydroxide and to form strong bases. Likewise, if you were to look at the periodic table and you have fluorine, oops, let me put the highlighter back on. If you were to have fluorine, chlorine, bromine, and iodine, you just remember these in a straight line. And if you were to pair these with a hydrogen, so for example, you've all have heard of HCl, known as hydrochloric acid. This is a strong acid, hydrogen fluoride, hydrogen bromide, hydrogen iodide, very, very strong acids. Yeah, so that's my overview of the periodic table, getting an introduction in how it relates to ionic compounds. Once again, if you like this video, please like, subscribe, leave a comment. I am going to be making videos as fast as my time allows. If there's a particular video you just really want to know the content now, you need a refresher on something, please just drop a comment and let me know. Thank you all for listening, and I hope you enjoyed the video. And stay tuned because It's Your Grade has been revived, and there will be many more videos to come. Thank you for listening.